Ratio tables are one of the more common ways to demonstrate equivalence, especially in scenario problems where it's like, oh, if you spent $20 on a ticket for one person, how many dollars would you spend on a ticket for 5 people or 10 people or 15? Ratio tables are pretty common, and you should expect to see them in a lot of your different work. So here's an example right here of a ratio table comparing red circles to blue triangles. Some ratio tables are very straightforward. They are multiples, essentially, of your smallest ratio or your starting ratio. Sometimes you will be able to use your knowledge of multiples, especially if your table is in order. So you can see here it goes 3, 6, blank, 12. Well, I think when you think about 3, 6, you think 9 should go in there. But we always have to double check because sometimes ratio tables don't go in order. This one, you can say 3 times 2 is 6. So 5 times 2 is 10. 5 times 3 is 15. 3 times 3, yes, this one is in order, so it should be 9. 3 times 4 is 12. And 5 times 4 is 20. However, ratio tables aren't always in order. This table you can see is comparing 5 purple squares to 12 green, whatever that shape is, and it does not go in order. So one really important thing to think about is checking your scale factor. Here you can see 12 times something will give you 24, that's times 2. 5 times 2, notice it has to be the same scale factor. 5 times 2 is 10. So your missing variable there is 10. But this one does not go in order because 5 times 3 does not give you 55. So don't just assume that it's always going to be in order. 5 times something is 55. I know that 5 times 11 is 55. So I'm going to have to go down and multiply 12 times 11, which gives me 132. The next column I have 12 jumping to 144. I know 12 times 12 is 144, so I have to do 5 times 12, which will give me 60 for this next box. Then I'm looking at 5 times something that equals 20. 5 times 4 equals 20, so I have to do 12 times 4, which would give me 48 in this missing box. And lastly, 12 times something equals 36, that would be times 3. So I'd have to do 5 times 3 equals 15 in this box. This ratio table has more of a concrete connection. It's not just comparing shapes. This is the number of tickets you buy and the cost of each ticket. So ratio tables do not have to have whole numbers in them. As you can see, the cost is $10.50. So we're working with some decimals here. You do not need to solve them in order. If you notice a relationship between these two before you notice a relationship between these two, that's fine. You can say, oh, I see that the decimal has moved over one space in this one, so this must be times 10, which would mean that this would be 10 tickets right here. Then if you go back and say, oh, 1 times something equals 7, well, that must be times 7. You can take your $10.50 and multiply it times 7 off to the side. You are more than welcome to do work in the side of your ratio table, so long as you actually fill it into the missing box, because when I do check them, I'll be looking for, do you have your work in the box? Lastly, I'm looking for a relationship between 1 and 22. I can recognize that that has to be times 22. So you'll have to keep multiplying or adding your way up if you wanted to do that. You can either multiply $10.50 times 22. Or you can build your way up. If you know that 10 tickets cost $105, then you can say, well, 105 plus 105, the cost of 10 tickets plus the cost of 10 more. 20 tickets must cost $210. Plus 1 ticket is $220.50. Plus 1 more ticket is $231.00. If you can add your way up and build your way up to that, then you don't need to do that giant multiplication problem. If you're okay with multiplying, you could have just multiplied it and said, well, that would give you the exact same thing. Oops. Can't really do that one. That would be 0, 0, 1, 3, 2 with 1, 2 decimal places, $231.00. Same deal. You can multiply if you are comfortable with that big multiplication problem with decimals, or you can add your way up. Either way, ratio tables will be something you encounter regularly in class, and they are something that we should be able to solve. I'm going to model one more in which I focus on the adding part as opposed to the multiplying, in case that went by too quickly. So, if you are comfortable with adding and not super excited about the multiplying, you can add your way and build your way up. So in this ratio table, we're comparing 5 puppies to 7 kittens. If I say that I know that I have 5 puppies and 7 kittens, and I'm trying to get to 10 puppies, that's just 2 groups of 5. But I have to add my 7 kittens as well. This is how ratios and fractions are very different. Because if we were adding this as fractions, this would be 10/7. But we're not adding fractions, we're adding equivalent ratios. So I would say 7 kittens plus 7 more kittens is 14 kittens. And I could fill in a 14 right there. If I did not know how to get from 5 or 10 to 125 with multiplying, I can add my way there, build my way up with addition. Let's see. I know that 10 puppies plus 10 puppies plus 10 puppies plus 10 puppies plus 10 puppies is 5 groups of puppies. That would give me 50. That's not exactly 125, but let's start adding some up. That's 7. Nope, that's not true. That's 14. You always gotta watch out. Plus 14, plus 14, plus 14, plus 14. 14 and 14 is 28, plus another 28, plus a 14 gives us 40, 56, 70. That is not the ratio we're looking for, but there's no reason that you can't add that one in to your ratio table to help you build your way up. Now that I have my 50 to 70 ratio, I can add quickly to get 100 puppies plus 20 puppies plus 5 more gives me 125 puppies. 70 and 70 is 140 plus 28 plus 7. 28 plus 7 is going to be 35 plus 140 is 175. Now notice that took me a lot more time then just knowing that 5 times 25 equals 125, and then multiplying 7 times 25. However, if you're really not comfortable with the multiplication, or if there's just like one step in your chart that is faster for you to add up than to multiply, that is always there as an option. You can also use multiplying and adding if you can recognize some multiplication problems, like this is times 7, so this must be 5 times 7. But there can be others where maybe it's harder for you to recognize, like 7 times 12 and 5 times 12. Either way, whether you recognize it or you don't, you have the option to add or multiply your ratios to build them up to find your missing pieces.